Hey guys, welcome back. Uh, how are you doing? So today we'll be solving another problem, and this problem is lead code 452, and this came up at Facebook interview. And so without much delay, let's directly jump into the problem statement. So basically, you can pause the video and you can have a look at this problem, but I have understood the problem, and this basically says that you have given a list of numbers, a list of like points, and these are points like on a scale on an x-axis. These are balloons, and the balloon diameters, let's say this one 10 and 16. So the from point 10 to 16, the diameter of x, this first balloon is there, and from point 2 to 8, the diameter of the next balloon is there. From point 1 to 6, the diameter of the next balloon is there, and from 7 to 12 is the diameter of the next balloon. And basically you need to find out like how many arrows you need to shoot, to pop these balloons. Like you have to find the minimum number of arrows you need to pop all these balloons. And definitely, as you can understand, like these will always be, like this, the starting point will always be less than the ending point, because it's on, like it doesn't go to negative. Even if it goes to negative, it doesn't matter. The starting point will always be on the left side, that is less than the ending point, and you just need to return the number of arrows you need at minimum. So you can pause this video and like read the problem, maybe think of a solution. But like the solution that comes up to my mind directly, right, understanding the problem, is a greedy approach. Because okay, let's first try to visualize this problem, what it's saying. So I have prepared a whiteboard for this, and I have made a like a point, like a number line thing. And so we'll just try to plot this balloon. So as you can see, the first plot is from 10 to 16. So a balloon is like that, like the balloon, it's something like this. So you can imagine like there's a balloon like this. Okay, so I think the circle is not correct, but it's okay, you can understand, right? It's from 10 to 16. So the balloon is like this, and it's like, you can assume it's a balloon. Oops, yeah, whatever. So it's a balloon like this, right? So that's the concept of the problem. And I would just not draw this part, because that would complicate this. So you can imagine this is one balloon from 10 to 16, and the next point is from 2 to 8. So I'll just quickly draw this so that it's easier for us to visualize the problem, because if you can visualize this problem, we can solve it very easily. And then we have 1 to 6 and 7 to 12. Right. So, what are the arrows you need? And you can you can basically shoot arrows along the y-axis. So basically, arrows would be from either this direction or this direction, right? So, but what we need to understand is like what is the best positions to shoot the arrow. So according to the solution says like the best position to shoot the arrow would be somewhere, like in this region, somewhere where these two balloons overlap, like intersect. uh, they intersect here also, right? They also intersect here. So two balloons intersect in positions. They are the best positions to hit an arrow, because if you hit an arrow here, you can only pop this balloon, the last one. But if you hit an arrow here, you'd be able to pop both of these balloons. And similarly, if you can hit here, you can pop both of these balloons, the second and third one. If you hit here, you'll be able to pop the first and the second one. So these are areas which you will try to focus. So these are the overlapping regions, and basically we need to find out like what are the minimum number of overlapping regions we need to find out. Basically we need for the arrow to be shot targeted at, so that we can pop all the balloons, right? So as you can see, if I could if I just target this zone, if I target this one, right, the middle one, I'll be able to pop 2 and 3, second and third balloon separately, together. But again, 1 and 4, the first one and the last one, still remain separately, and I don't need two separate arrows for that. So in that case, my total number of balloons needed is 3. But if I can pop the balloon, if I can shoot an arrow here, like the first and the second one overlap at this point from 2 to 4, 2 to 6. And if I could shoot an arrow inside this zone, like from 10 to 12, and so basically here, uh, I can pop all these balloons with just 2 arrows. So that is the solution to this problem. And if we think of an approach, if we could, as you can see, when we set all this in a number line, they are all sorted according to their start or end, whatever you consider, but they are all sorted, right? According to these indices, according to these numbers actually, so from where they start and from where they end. And now if we could just iterate over this array, iterate over like each of the balloon, and just keep on checking if there's an overlap, then we shoot an arrow, right? If there's an overlap, right, and as soon as there's an overlap, you shoot an arrow and you pop this balloon, right? You pop this balloon and we pop this balloon, and in that case we will not find an overlap here because we have already popped it. So you go ahead, you find an overlap here, so you pop this balloon and you pop this balloon. So that's it, very simple. It's a very simple greedy approach, greedy solution that we can design and solve this problem. So without further delay, let's directly jump into the problem and code that out. So I'll be using Python language for this, and in Python, we'll first sort this array, and for sorting this array, we'll use the ending. Like the ending time, because why am I using the ending time? Because that is much more uh, appropriate, because I maybe if we take the starting time, there will be a few edge cases will not pass, and we'll have to check that. But I think we have solved problems like this. There's a problem called merge intervals, which also has a very similar concept where we need to find out the overlapping sectors, overlapping areas. So we'll be sorting it based on the ending coordinate. So we'll just use the sorted method of Python. We'll sort points, and we'll be sorting based on the you know um, the second index, like x of 1, right? Cool. So that's what we want to sort it. So since the array is now sorted, like we need how many arrows do we need at minimum? So there will always be at least one balloon, right? Okay, so in this case we need to understand like what is the constraint. So they have not explicitly defined anything. So let's take let's write a corner case for, like, if we are not given any balloon in the array, input array, then we just return 0, right? Because if there are no balloons, we don't need any arrow, and if there is a balloon, we need at least min arrow as 1, because we need at least one arrow to pop at least one balloon, right? And we'll start from this first node. So current node, we'll just take it as like first node would be the current node, not exactly node, the balloon I should say. Now we'll just iterate over it since this is a sorted array. So for each point in points array, I'll just iterate over it, and I'll just check if there is an overlap. So how will I check if there is an overlap from the current balloon, right? So if the current ending, if the ending of the current balloon has is greater than or equals, it's actually okay, wait 1 second. If the current balloon ending has to be less than, right? So the current value ending has to be less than the starting of the element we are, okay, yeah. So okay, so for P, so it is the iterating balloon, and we want it to be less than, because that is the one on the right. Okay, so that is one on the left, that is the one we are iterating over. So if the starting point is less than like the ending point of uh, ending, that's fine. But if it's greater than, so basically if the starting point of this is greater than the ending point, it's a problem. So that means there's an overlap. So that's the overlap condition here. Will be, I think that makes sense. Yeah. So in that case, we need another arrow, right? We just increment it by 1, and our current becomes this node becomes the current node. So if we could relate this with an example, right? So so when we start, P is this one, right? This balloon is P, and because we have sorted according to this index, ending index, and P is this one, current is this one. So current is this one. So P and current, this basically doesn't satisfy exactly. So if like the current, so the ending point of the current one, so ending point of this one, uh, if it's less than that starting point of this, it's not right. So we keep on going and we see that P becomes this one, right? Now for P, this one, the condition is satisfied. So this part is an overlap. We can understand that the starting point of P is definitely, like the starting point of P is greater than the ending point of, uh, like ending point of the current one. So there's an overlap, and we count it, and then we go ahead, set the current one to P, and we go ahead and keep on calculating it. That's it. A very simple logic, and I think that's most of our algorithm. um, so that's it. By the end of the entire loop, min arrow would have a solution. So let us try submitting solution, running it and then submitting it. I think yes, it passes the basic test cases. We'll just try submitting this, and yeah, let's see. Okay, so we get around 21%, but that's fine because submitting it again and again, as you have seen, like I've already submitted quite a few times before solving this, before recording this. So yeah, that's it for today's video, and that's how you can solve this amazing Facebook interview problem. Hope you guys liked the video and liked the channel. So good luck with your interviews. Enjoy it.